So number 2 on this class opener, it says state the x-intercept. How do you find the x-intercept? Set y equal to 0 and solve. So I really have the above equation, negative 2x squared minus 8x plus 1, and we're going to set it equal to 0. Instead of writing 0 on the left side, I'm going to write 0 on the right side. And now I need to solve this thing. So a lot of us freak out when it comes to solving an equation like this. So right here we're going to use the quadratic formula, and I always start the quadratic formula by writing it with parentheses instead of variables. So I'm going to plug in my b value of negative 8, my b value of negative 8, my a value of negative 2, my a value of negative 2, and my c value of 1. And focusing in on the discriminant value, the value inside the root, what is negative 8 squared? 64. So we have a 64. And what is negative 4 times negative 2 times 1? 8. So that's a positive 8. So I'm going to put a plus 8. And that is inside of the root. We still have an 8 on the outside and a plus minus right in front of the root over negative 4. So let me rewrite this one more time. I'll have an 8 plus minus the square root of 72, correct? Yeah. Over negative 4. And now at this point, I'm going to focus in on what? The square root of 72. Whenever you have this type of answer, you need to simplify the radical first before moving on to anything else. Now, for some reason, that was like the square root of 17, you'd be done. But because it's 72, you could break it down. And what you want to do is break it down with the highest perfect square number possible. So some of us are thinking 9 times 8, right? But a better one is 36 times 2. Let me show my work to the side right here. If I take the square root of 72 and break it down to 36 times 2, and I split the root, I'll get 6 square root of 2. So what I want to do is replace square root of 72 with 6 square root of 2. So I'll have 8 plus minus 6 square root of 2 over negative 4. Now at this point, I'm going to reduce the whole thing by 2. Okay, so if I reduce the whole thing by 2, this is going to become a 4, this is going to become a 3, that's going to become a 2. 4, 3, 2. So let me rewrite my answer over here. It's going to be 4 plus or minus 3 square root of 2 over 2. And this negative sign down here, I'm actually just going to move the negative 2, the negative that belongs to the 2, and move it up to the top. Now normally you'd change this sign and this sign, but because there's a plus minus, you don't have to worry about the second term, only the first term. So my final answer will be negative 4 plus minus 3 square root of 2 over 2. Another acceptable answer would be to actually separate that denominator and get negative 4 over 2 plus minus 3 square root of 2 over 2, which means you'll have negative 2 plus or minus 3 square root of 2 over 2. So on number 4, we could move over the 48 by subtracting 48 and subtracting 48, which means we'd have to rewrite it. X squared minus 22x minus 48 equals 0. And you guys mentioned we could use the quadratic formula, and that's absolutely true. But what's a better option here? What was the very first way that I showed you guys how to solve these quadratic equations? Factoring, splitting, and solving, right? So always go with that first method. Attempt to factor. What times what is negative 48 that if I add together, if I combine together gives me negative 22? What times what is negative 48 that if I combine together gives me a negative 22? Negative 24 times positive 2, guys, right? And because of that, we'll be able to split it and solve. Split right there. And now we just need to solve them. And we'll get x equals 24. And also x equals negative 2. So yeah, you could use the quadratic formula. It's easier to factor, split, and solve. Always try to factor, split, and solve. Moving on to solving 2 by 2 systems. This is going to be all over the test Friday. It's going to be at least 4 of these guys, I think. Maybe 5. 3 or 4. 5. I don't know. Somewhere. I'm not done with the test yet, actually. So we're going to have a couple of these. And let's start by focusing in on number 5. The goal is to get either x's or y's to cancel. And you're going to have to modify maybe one or maybe both to get them to cancel. So what do you guys want to cancel, x's or y's? X's. I want to multiply by -2 to make this 5x a negative 10x, so it'll cancel with the bottom 10x. So if I do multiply by -2, I will get negative 10x. I'll get positive 6y. And I'll get negative 36. Okay, and the bottom one, I'm not going to do anything to it. I'm just going to rewrite it. And because we're able to combine now, that's what we're going to do. We're going to combine and cancel. And something weird happens. The x's and the y's cancel. Even though we only went for the x's, but the y's also canceled here. So what do we end up with? We end up with nothing on the left side. It equals something on the right side. Now we know that that's impossible. 0 cannot equal negative 33 ever. 0 just equals 0. So what do we say? We say no. We say no solution. No solution. Okay, so that's a special case. It's not going to happen that often, but it might happen, right? Let's move on to the next one. Oh, by the way, it doesn't matter if this happens on a 2x2 or a 3x3. Bottom line is no solution, right? Even a 4x4 or even a regular equation for that matter. If you're solving an equation and you end up with something impossible like 0 equals 5, you're going to say no solution for the regular equation. So keep that in mind. When it's impossible, you just say no solution. Let's take a look at number 6. This picture didn't come out that well. It's a x plus y equals 1, and we need to cancel it out with the bottom. So I'm going to multiply the top equation by 2, and I will get 2x plus 2y equals 2, and the bottom I'm just going to rewrite it. And as you could see, when you combine the lines, the x's cancel, the y's cancel, and even the numbers cancel. So you have 0 equals 0, which means infinitely many solutions is the answer here. And again, even if this happens on a 3x3, if everything cancels and you get 0 equals 0, you could stop doing what you're doing and just say infinitely many solutions. Okay? Let's move on to a regular 2x2 that you actually have to solve and find both answers. So how am I going to solve this one? Let's cancel out what? X's or y's? X's are better because all you have to do is modify the top equation to get the x's to cancel. If you say y's, you're going to have to modify this one and this one to make this one a negative 12 and this one a positive 12. So the easier route, the shorter path, is to cancel out x's by multiplying the top equation by what? Negative 2. And when I multiply the top by negative 2, I get a negative 6x. I get a positive 8y. I get a positive 20. And the bottom one I'm just going to rewrite. And now we're going to combine and cancel. And I'll get 11y equals negative 22. Got a brain fart right there. Okay, so now let's divide by 11. Divide by 11. Y equals negative 2. Ta-da. We have one answer. We need the other. What do we do? Plug it in. Plug it into which one? Top or bottom? Doesn't even matter, right? Let's go with the top. So you're going to have 3x minus 4y, but instead of y, I'm actually going to plug in my negative 2, and it should equal negative 10. Why did I put 11? I have no idea. Now it looks like 110. That's really ugly. Let me change that. Okay, so the y value is negative 2. I took this and plugged it in right there into the y. So we have 3x plus 8 equals negative 10, which means if you subtract 8 on both sides, you get 3x equals negative 18, which means x equals negative 6. Yay? Okay, so the answer, you're going to write it as an ordered pair. Negative 6, comma, negative 2. That is the answer right there. negative 6, comma negative 2 as an ordered pair.